Hello friends, the topic for discussion is merge sort. Actually, a merge procedure is the crux of this merge sort. It is the central procedure which merge sort algorithm uses. So let's first understand what is merge procedure. So merge procedure is like this: given two sorted arrays or two sorted parts of the same array, merge them in order to get a bigger sorted array. So for example, let's say we are given these two sorted arrays, array A, which is looking like this, ten, 15, 25, 35, and there is array B which looks like this. And let's say 30. So what we are asked to do is merge these two arrays A and B in order to get a bigger sorted array. Let's say we'll store the sorted array in the third array C, which we'll have to use in order to merge these two arrays. So let's say we have this temporary array C, which we'll be using to store this sorted array. So the merge procedure goes like this: we'll take one variable I here, another variable j here, and one more variable k here. This is 0, 1, 2, 3, 0, 1, 2, 3, 4, 0. So the idea is to get this array as the result of merging these two arrays, and the C should be sorted in, let's say, ascending order. So the first number which will come here will be either this number or this number, because this is smallest in this array and this is smallest in this array. So the number which will come here has to be from either this place or this place. So let's compare these two. So I'll compare 5 with 10. So 5 is less than 10, so I'll copy 5 here. So after copying 5 here, I will move this because this is the place where the next number will come in this array C. So k will be going to the place 1 or location 1, and also I will move j because I have copied from array B, right? Because, and then the next number will be either this number or this number. So I'll compare 10 with 12. So 10 is less than 12, so I'm copying from A. So I'll copy 10 here. As soon as I copy 10, I will increment both k and the array variable from where I have copied. So I have copied here in C. So this is the place where next number will be copied. I have copied from here, so I'll increment I also. So again I will compare A of I with B of j. So A of I is greater than B of j. So I must copy from array B. So I'll copy from array B. So the number is 12. So copy number 12 and increment k and also j. So then compare 15 with 14. So 14 is smaller than 15. So I copy 14. So increment j because copied from this array. Increment k because this is the next location in which the next number will be copied. So compare 15 with 28. So 15 is less than 28, so copy 15 and increment the variables. As we have copied from A, we incremented I. So compare 25 with 28, so 25 is smaller than 28, so copy 25 and increment I and K. So 35 is compared with 28, so 28 is smaller, so 28 will be copied and J will be incremented and also K will be incremented. And now 30 is compared with 35, so 30 is smaller than 35, so 30 will be copied and increment K, so K will be brought here. Now there is we have copied from this array B and we'll increment J also, but J will cross the array boundary, right? So array B is completely exhausted. So now whatever elements are there in array A from this position onwards, they will be copied as it is. For example, we have only one here, but if we had few more like 35 and 40, so both will be directly copied because this array B is completely exhausted. There is no element here to compare with, and all these elements remaining from this 35 onwards will be greater than 30, so they will be copied as it is one by one. So I will copy 35 here and then I will increment K and also I, and I'll copy again 40. So thus if you see then I'll increment I, so I will come here and K will go to the next place. But if you observe now, the array is also exhausted, there is no more element left in array A. So we'll stop here our procedure. So at the end of this procedure, if you see array C is ordered in ascending order. So it's in fact the merging of array A and B in the ascending order. Okay, so that is merge procedure. So the idea is very simple. If I repeat one more time, I'll take one variable I, which I'll initialize to this position, J will be initialized to this position, and K will be initialized to this position. C is the array in which will merge this array A and B. So A of I will be compared, A of I will be compared with A of J, right? If A of I is greater than A of J, so A of J is smaller, that means A of J is smaller, so we should copy from this is array B, A of I will be compared with B of J. If B of J, it's now here B of J is smaller, so we'll copy from B array. So we'll copy in C array, C of K will be getting B of J. So as we are copying from array B, we'll increment J and we will also increment K, right? So this procedure will go on till we exhaust either array A or B, right? So if this is not true, we'll copy from array A like this, C of K is equal to A of I, and as we are copying from array A, we'll increment I plus plus and also K plus plus, right? So we'll put this in loop till our I is in this range and our also B is in this range. If one of those variable gets exhausted, right, we'll quit this loop and we'll copy the remaining the elements from the array which is not yet exhausted or which is not yet finished, right? So that's merge procedure, which is the central part of this merge sort. Now let's see merge sort algorithm. So here is the merge sort procedure, void merge sort. So to this merge sort procedure, we'll be passing an array. We'll be passing an array. Also, we'll be telling to merge sort where the array starts and where it ends. Array is starting at L and it is ending at R. So before doing any procedure, we'll check whether there are some elements in this array or not. That means if L is less than R, so for example, if this is the array passed, so this will be our L and this will be R. So if L is less than R, that means there are some elements in the array, and if there are some elements in the array, then only we'll be sorting this array. So first check if L is less than R. So if it is so, what we'll be doing here simply is merge sort. In merge sort, we simply find the center of this array, right? And we'll say this is my mid. So from L to mid will be my left part, from mid plus 1 to R will be my right part. So I'll be sorting L to mid, and then I'll be recursively sorting this L to mid, this left part, and then the right part, right? So if L is less than R, I'll partition this array into two parts, as merge sort is a divide and conquer algorithm. So I'll do this partition like this by saying mid is equal to L plus R by 2. I'll be simply finding the center by L plus R by 2. So there are no efforts required to divide this array into two parts. So in case of quicksort, we were doing a lot of work in order to get this partitioning, right? So we were doing actually a lot of work, like to divide this array into two parts in case of quicksort. But here we need not do that. Simply do one arithmetic operation, and we'll get the division of this array, right? Now from L to mid is my left part. So I'll call merge sort on this. Merge sort on array is same. It is starting at L, but it's now ending at mid. So this merge sort call will give me this left part sorted. So now once I get the left part sorted, I'll call merge sort on the right part. Right part array is same. It is starting at array is same. It is starting at now mid plus 1, and it's ending at R. So this call will give me this part sorted. Now I have two parts of this array which are sorted. This is sorted and this is also sorted. Now I'll call merge procedure on this part, and this merge procedure will give me the array A sorted. So I'll call merge procedure. Merge procedure, I'll tell I have an array A which is starting at L and whose left part ends at mid, and right part is starting at mid plus 1 and which is ending at R. So this merge procedure will merge the array which is starting at, merge two arrays or two parts of the same array which are starting at L and ending at mid. The other one is starting at mid plus 1 and ending at R. So that's very simple merge sort procedure, right? So thanks for watching.